Hello everyone, welcome to a new scientific moment. For the new joiners, I want to share with you what a scientific moment is. This is a space of talks. I made to technical talks. The idea is to share every knowledge about the technology we work with, like blockchain, like programming language, etc. And I want to invite you, if you want to give with us a talk, you can contact us through the open Slack channel that we will share it through the comments, or through the research forum. You can contact us if you want to give a talk with us, a new scientific moment. Today, we have a talk with the people of Defiant. They are going to explain us why they choose Flutter to build application on top of blockchain. They will build a scalable, flexible, and beautiful application with lower the barrier of entry to the crypto world. So welcome, Ivan. Hello.
Hello.
Welcome,
Hi,
Juan Pablo. So, okay, good luck.
Thank you.
All yours.
Great. So let's start with this. I'm going to share my screen. Let me know if you can see it in the comments. I don't know.
I can see it.
You can see it?
No,
oh, I cannot see it. Ah, you cannot?
No.
I don't know if Francisco has to add him himself. No? Again? Oh my. Things that happen on a live presentation. Why is it not showing? Here we go again. It says here it should be live. Oh my.
Do you want me to share it?
You have it there? Yes, please share it. Here. I think it's... Yes.
All right.
Did it. Live things. Oh my. Okay, so let's get started with this. My name is Ivan. I am a software developer and I work for Defiant Wallet.
My name is Juan Pablo. I'm also a software developer at Defiant Wallet.
Right. So first of all, thanks to the RSK team and the SIMO team for inviting us here today. We really like to get in touch with our community, and we also love talking about technical stuff. So here we are. So a little bit of intro about Defiant Wallet for those who don't know what the wallet is. Defiant is a wallet that is self-custodial, which means you have the keys all the time, and it has a peer-to-peer marketplace where you can trade with other people trying to buy or sell. It includes a cash-in, cash-out section for you to change crypto for fiat for various countries and various currencies. And we implement a lot of protocols in a native way. We integrate Uniswap, Sovereign, and a few more. And also we integrate Wallet Connect, that it's a protocol for connecting to dApps on the web. You read a QR code and you are ready to go. So that's the small intro. And let's get started with the technical stuff, because that's why we're here. So this talk is called Why We Chose Flutter and You Should Too, choosing a stack that is up to the crypto context. So a bit of recap. We started the project in 2019, and we said, okay, what do we want to do? There were a lot of people selling and buying peer-to-peer in Telegram groups and Facebook groups, so we wanted to tackle that market. We wanted to give a platform for them to sell and to buy without having to go to channels that were not meant for that. So we said, okay, let's build a platform that doesn't hold the funds of the users, that it's only for them to interact with each other. We don't want to do anything with that. And the wallet started with that. And then we added the wallet and the protocols and all those things. But the original goal was that, and that is still one of the main goals. So we said, okay, let's build an application. How hard can it be? It wasn't so simple. This is week 1, maybe. Let's build an app. This is week 2. Why did we decide to build an app? So the first thing we thought, okay, which platforms should we support? We wanted to give a simple experience. So we said, okay, let's go with maybe mobile. We had all these options. We have web, Android, iOS, desktop. Choosing a platform to build for wasn't so easy, because if you want to build for web, you need web developers. If you want to build for Android, you need Java, Kotlin developers. If you want to build for iOS, you have Objective-C, Swift. You need a Mac. We didn't even own a Mac to build, so it was a problem. So we started thinking about options. This was our situation. When we started, we were only 3 people, and 2 of us were developers, so it wasn't so simple. It wasn't fine. So we said, okay, what should we do? What should we do to make it simple for us and still give a good product to the people, right? So we said, okay, let's go with cross-platform. We write one code, one large code base, and we build for the different platforms we want to build. So we said, okay, let's choose a cross-platform framework to use. It shouldn't be too hard. It was hard because you have 25 different options, and this list is just a few of them. You have Xamarin, Apache Cordova, jQuery Mobile, Kotlin multi-platform, React Native, Flutter. This is just a small subset of that gigantic list we came across. So, okay, let's start deciding which one we want to do. We had worked before with web-based frameworks like Apache Cordova, so we said, okay, what are the pros, what are the cons? And the pros are that they are mostly based on built on top of JavaScript, which is a very popular language. It has a lot of libraries, a lot of community. You can find developers for it anywhere. And when you want to port it to the web, it's really simple because it's built with web technologies. The cons were that the UI language isn't really so simple. It has a lot of weird stuff, and it's not easy to build with it. JavaScript is a language that is really good for a lot of things, but it's not really good for soundness and maintainability. So when you have a large code base, it gets messy and complicated. So we didn't like that. It doesn't have types. You can use TypeScript, of course, but it was complicated at the moment. We didn't know TypeScript, so we weren't going to go that way. And usually the performance of these frameworks is not really good because it's like a web view and you build inside that web view, but the renderer is... So there were a lot of cons. We said, no, let's go with another thing. React Native. Everyone is using React Native. We said, okay, let's give it a try. Everyone is talking about it, so we should try it too. Indeed, we tried it. Here's what happened. We said, okay, the pros are it's based on JavaScript. It has a good development flow, has a lot of libraries and plugins. It has good performance. It has a huge community. And it renders to native components. So you build your components in React Native, and then the framework does what it has to do to make sure the components are rendered on iOS and on Android the way they are supposed to do it. And it's somewhat easy to learn. The cons were that it's not typed because it's JavaScript. The construction of the UI, it's a bit complicated. You have to know HTML and CSS and a lot of all those things. And even though you know that the UI construction is it's tricky because it's not as streamlined as it should be, or as one is expected to be with it. So that's that. And then when you build for the first time your React Native project, React Native doesn't give you anything out of the box. You have a blank canvas and you start to build on top of that. But there's a lot of frameworks for building UI, Material, Cupertino, and all those, but they usually don't work well together. So you pick an up bar here and a bottom there, and it's like they are not prepared to be mixed. So the other thing is when you build a React Native project, you have Expo and React Native, the clients for the command line. And when you build with those, if you build with Expo, you cannot use native plugins for the app. So you want to use the camera, you have to close the project. Weird. So you go to React Native, but React Native it's not so easy to build with. So we encountered a few things that didn't feel right with us. Of course, it doesn't have support for desktop, and it doesn't support web if you are building something really large, because you start to have a lot of dependencies and it gets messy really fast. And of course, if you work with JavaScript or NPM project before, you know them, node modules folder ends up like this. So it's a problem. So we said, okay, React Native, it's okay. We were not convinced. So we started searching and we came across this, Flutter. And we were hearing about it and we knew people were using it, but we said, okay, let's give it a go. So, Juan? I think you're muted.
Sorry for. Oh, yeah. No, it's not muted. So, what is Flutter? Could you please go to the next one? What the legend says is Flutter is a Google UI toolkit for building beautiful natively compiled applications for mobile, web, desktop, and embedded devices from a single code base. That's too large definition for Flutter. Please, next one. What we like to say in Defiant is the thing we use to build Defiant. Well, Flutter is a cross-platform framework, as we know. It builds for 3 different platforms, web, mobile, and desktop, with a single code base. And it's really centered in a very, very fast development cycle, so that developers don't have to care that much about, for example, things like UI and making the app work. Okay, some memes already there. All right, let's talk about widgets. Widgets are the main concept in Flutter. Widgets are like components or classes, you can call it, that make a lot of things. They are multi-purpose. Most of the things they make is UI. So widgets defined in the code construct UI. But widgets are also made for other things like in user interactions, for example, state management, and other things, for example, translating the whole app. So as you can see, Flutter also packs Cupertino widgets and Material widgets. What are these widgets? So Cupertino widgets are widgets that are designed to emulate the look and feel of native iOS components. And on the other hand, Material widgets are widgets that emulate the Android framework components. So Flutter gives us a lot of freedom here. We can choose to make the application platform specific. So if you want to display an iOS-like back button, you can. But if you want to display on an iOS platform the Android or Material back button, you can. So this is really easy in Flutter. I think that's a really good perk of Flutter. Okay, next one, please. Okay, talking about performance in Flutter. Flutter has two compilers or two compile modes. The first one is the just-in-time compiler. You gotta have here is on languages like Java or JavaScript, where the code is compiled as soon as it's going to be run. So when we push code to the compiler, it gets compiled and executed at the same time. So this allows for a much better debugging experience since not all the application code base has to be compiled, just the part where we're watching or we are running. Flutter has this amazing feature called hot reload, which enters, how can I say this, which compiles and executes the code in just 1 second or top 2 seconds. So the development experience is really good from that part. But we don't want to ship an application that is not that good performant and for the final user. So that's why the ahead of time compiler exists. This compiler compiles to native code, depending on the platform. You would want this build mode for building the application in release mode. Okay, in this mode, there is an increase in the startup time. A decrease. The startup time is less. The application runs a lot more smooth, and because of a lot of the development stuff is removed from the package, and also the package size is a lot less. Okay, next please. Okay, here's the image with a lot of nerd info. Okay, first we have the framework itself. It's written purely on Dart. As you can see here, we have the Material and Cupertino widgets. These libraries are the base libraries for designing UI. But we have some other more like lower layer widgets, which handle the rendering, the animation, and the painting of the screen, and also the gestures, which you won't be using that much, but you can use in a daily basis when you're developing apps. So the next layer is about the Flutter core engine. Flutter core engine ships with Skia or Skia, I don't know how it is. This Skia is the graphic rendering engine. It's very powerful. The animations run really smooth, and also ships with the Dart runtime and the platform channels. The platform channels allow us to communicate with the specific platform shell. Sorry. For example, you can communicate with the undershell or the iOS shell or the Linux shell or the Windows shell. So that's the main stack that Flutter has. Next one, please. Okay, we're done selling you Flutter technically. Let's go to the development experience. Okay, Flutter has a really great community. It's growing every day at exponential ways. I think that's really good for an open source project of this size. It also has a perfect integration with some IDEs, Visual Studio Code and Android Studio with IntelliJ. They have a lot of snippets and shortcuts and things that make the development experience really fast and really useful. I already talked about the hot reload stuff. I think it's amazing. It's really fast and that is super simple. It also has a really good testing framework because you can test only widgets let's say, for example, in other applications, you have to run the application, wait till the screen it's complete with all the data. No, here in Flutter, you can have widgets testing, so you can test the widget renders with the correct value, and that's it. You don't have to test the whole application. Also, Flutter comes with some dev tools, which I find amazing. Some of them you will use it on a daily basis. And other ones are used based on your needs. Two that I really like are debug painting. This one kind of draws the widget limits, so you can see how much space is being used by, for example, a padding or a container, or maybe see how the column is aligned. The other one that I really like is the widget inspection, that when you click on a widget on the screen, on the running app, and the ID automatically takes you to the place where it's declared, a widget is declared. So I really like those. But in case this is not a common case, because Flutter is really performant, it's really smooth. But in case you want to get more performant, you can measure with these dev tools the CPU, the GPU, the RAM that is being used, and the frames per second. Maybe if you want to see another detail to add, is Flutter renders at 60 frames per second natively. So also you have a network monitor. Sorry. Network monitor showing the incoming and outgoing requests. Okay, I give you the microphone, Ivan.
Thank you. Sorry for that. Right, so the last bit, it's about Dart. Flutter, as you know, it's not a programming language, it's just a development framework, and it builds on top of Dart. Dart is the programming language, and Dart has a lot of really nice things, but we'll talk about just a few of them. One of the most interesting and important ones, I think, is the type system is really good. It's really smart. You have what I call a soundness, and what that means is you declare a variable, and you can go var a equals this string. That a is going to be a string all the way. It's not going to change, and you cannot change it in a later time. Not only you cannot change it in runtime, but you cannot change it in offline. I mean, when you haven't compiled yet, the static analyzer is going to say, no, this is a string. You cannot put a number here. So that's good for making sure you don't make a lot of mistakes. Also, you have the option to declare something as dynamic. Imagine you have a request that comes from the internet and you don't know what that's going to be. So you say, this is going to be dynamic. And as soon as that variable takes a value, then that's going to be whatever you received from the request, right? So you have that flexibility to play with that. And this is nice for type inference. So when you say something, it's going to be, and the analyzer, it knows what you declare soon. So you don't have to be declaring, this is going to be a string, this is going to be a bool. You say final x equals 5, and that's a number. It's always going to be number. So it's easy to work with it. And the last thing is, as of version 2.12 of Dart, we have null safety. Null safety is a feature that a lot of languages have nowadays, and it's really good. When it helps you develop, taking care of you not calling something that is null when it's null. So if you say 5 plus x, and x doesn't have a value at the moment you call it, the compiler is going to know before you compile the code. So it's not going to allow that unless you declare that x as something that should be null at some later point in time. but it's really good to avoid making mistakes in shipping a code that has bugs and runtime. So that's the Dart thing, and there's two honorable mentions to add. The first one is it's a protocol that's been added to Dart in recent version, and it's still in development. We are going to include some of these in our app maybe soon. We're working with it. That's called FFI, and what allows you to do is to include Rust libraries or C libraries inside your Dart application, and without having to build a specific plugin for that library, whatever. So what you do is you construct bindings for that library, and you call them from your Dart code. So you can access, I don't know, maybe a Bitcoin library that is developing Rust, and you use it with your Dart code. You don't have to develop that library yourself. It's really good. And Rust is really sound. Rust and C are really sound in developing, so you are sure they are performant and your app is going to be robust. And the other thing is packages. There's a lot of packages to pick. The pub dev is the repo where you find those, and it's enormous, but also it's really, really, really simple to develop a package for your application. Defiant at the moment, it's split in, I think, 5 different packages, one for the app and 4 for Dart code that is just Dart code. So it's really simple to make modules and make them work together. And also you can develop native libraries. So and you want to do something weird with the GPS on your Kotlin code. So you build that Kotlin code, you include it in a Dart plugin, and you include it in your Flutter app. It works without problems. So enough of that. Shut up and give us a live code. Let's, I don't know how we are on time. I think we have like 5-ish minutes. I see there's a lot of questions going there. So I'm going to try to be as fast as possible with this. If the guys don't have a problem, let's try to, we have time, nice. So, okay, bear with me because this is live coding and this can go wrong at any moment in time. So I'm going to try to share my screen again. Let's see if this works. Yes, share. Yes. You can see me and you. I don't know.
I don't see you.
I think Francisco has to add it, but I can see my screen here. Yes. So you can see it here. Great. Right. And Juanpi, can you see my VS Code?
Yes, I can.
And the CMO thing over here?
Yes.
Yes? Great. So this is Flutter. We wanted to give you a quick view of how fast we can develop stuff with Flutter. This is vanilla Flutter. It doesn't have anything other than what comes with the framework. Yes? So it's already running. This is compiled to Linux because we've been talking about cross-platform. Defiant runs on Android and iOS, but it can also compile to Linux. It has a few things to be worked with, so it's not perfect because you have to make conditions for different things, but for the most part, it's really great. So this is the basic application. It has nothing, so I can say color white, and you can see it runs like that and reflects in a fraction of a second. If I run this on my phone, it's mostly the same speed, and it runs on the phone. So you can see it really, really, really fast. Yes, it has to be plugged in with a cable, but apart from that, it's really good. So I don't want to show you a white container. So let's start with a stateful widget. I'm going to be talking a lot while I do this, so I'm really sorry. So you have 2 types of widgets in Flutter. You have stateful widgets and stateless widgets. As their names imply, one has state, the other doesn't. I'm going to go with a stateful widget here because it's I want to store a few things. Notice that every time I hit save, you can see that the little white dot here goes away. It's because I saved my code. The app reloads. So let's start with something simple. I'm going to build a scaffold that's integrated. I repeat, all this comes built within the Flutter library, right? So this is a scaffold. It's going to be have an app bar with a title. There is a text. It's going to go, hello, Simon. Hi. Right. So, hello, Simon. Cool. So that's the app bar, and now let's add the body of this. Body container. It's going to be a container with the width of the whole screen. So media query of context. Come on. Size width. Yeah. So you cannot see that, but believe me, it's there. I'm going to add a child that is going to be a column. We have our own snippet pack because we use it every day and it's simple to use snippets. And that's a column that is center. Let's add a spinner running in the middle. So here it's going to be 50 units of size. And it's going to go, yeah, that's that. Okay, so I have my size box and I want to wrap this. Notice that the contextual menu is really good. You can wrap a widget inside another widget. As Juan said earlier, Flutter is built all with widgets, so it's it has a tree that grows like in this direction. So I'm going to wrap this widget with another column. I'm going to add the same properties here and main exercise, minimum, right? And a text that goes loading stuff. Yeah, and also a space because it looks ugly. So that has 60 lines of code, and I have not built any logic into it. And it looks great. It doesn't do anything, but it looks great. So let's do this. I'm going to call a function that's going to be future void init widget. It's going to be async. Flutter has the async await pattern, so it's really good if you know what I'm talking about. So await future delayed duration seconds 3. And I'm going to create a variable. It's going to be bool. Oh, let's go with var loading true. As you can see, I declared it as var, but when I put my mouse on it, it says it's a bool, and it's going to be always a bool. So this doesn't do anything. I know. I'm going to call this function. Flutter has a really good system for interacting with the life cycle of the widgets. So you can tap on anything that happens when you start, when you finish, when you leave the widget, when it pauses. Let's go with init state. That is the function that gets called when you start your widget. And I'm going to call init widget. I haven't saved it yet. Let's call loading equals false. And if mount set, if the component is mounted, set the state, right? So this is going to be reactive and it's going to change the state of the screen and set this loading to false. And I'm going to put an if here, saying underscore loading. And when this changes to false, this column, this whole column, is going to disappear. right? And as you can see, it's really simple to put conditional rendering inside code. So it's really good. If you work with other things that make you do string interpolation and weird stuff, this is really good. So there's that. And let's see if this works. I'm going to hot restart the application. So here, because as I change my state here, and when I call this init state, this is called when you first start your widget, and it's not called any other time later. So you have to reload the whole screen to launch it again. So restart. Whoop. It went here, 3 seconds, and poof, it's gone. Nice. So we have the first thing. The other thing I'm going to do is I'm going to call make a column here. Else this is going to have a text field and a text. This text field is going to have hint. Oh, sorry, decoration, input decoration, hint text, give me text. Yeah. And this is going to have a controller. All fields have to have a controller. So final underscore controller, it's a text editing controller. And one thing to keep in mind is when you dispose your widget, you should make sure you dispose your controller so that they are not kept in memory. Dispose, right. And here I'm going to add the controller.text. So this is going to be the text of whatever I put here, but I haven't declared the controller. So controller. If this is all right, I'm going to reload again because I call this final, and finals are only initialized at the beginning. So reload. Give me text. Nice. Let's add it some padding, symmetric padding. Notice that I haven't added anything that is not mainline Flutter. Yeah. So horizontal. Guys, let me know if I'm losing minutes like a crazy person. I hear silence, so let's suppose it's all right. So your text. So when I start typing, hola, I missed something important. Sorry, unchanged. I need to reload the state of the screen. So if mounted set state, this is going to call the renderer. So it's going to make sure I have repainted my screen when I change the value of the controller. So let's go again. Hola. Hello. Hi. Nice. As I write here, you can see that the text goes there. And I'm going to do just one last thing because if I have time, I think I have like 2 minutes. So I'm going to make a raise button that goes hit me on press. On press, this is going to be a function that I'm going to declare over here that is going to be void on press, and this is going to call show dialog. That is a function that builds a dialog, as the name implies, with the context. That's the context of the whole screen, and a builder with a parameter that it's empty, other dialog, content, text. I'm a dialog. Title. And last but not least, the action to go back. So flat button, child text, Okay, compress navigator of context dot pop. The router of Flutter is really good also. So I think this is all that I wanted to show you. I'm going to restart the application and let's see if this works as intended. So loading stuff, 3 seconds. Give me a text. This is the text. And when I press hit me, it calls the function onPressed. Hello dialog, I am a dialog. And that's all there is to it. And I did it under 130 lines. So I think that's it. I have given you Flutter as fast as my hands can write it. Okay. I think we have a few questions. Right. Let's see. And do you want to read the one that, or does anyone have anyone commented in the comments?
Yeah, I saw one question. Does Flutter have any limitations? For example, if you use an abstraction level, you will use precision or control.
Do you want to take it?
Begins, maybe?
Sorry?
I think
about
it's
what?
About begins.
I don't know.
I don't know if that is exactly your question.
Okay. I don't have limitations. I don't think it works on the precision of control. I think you mean about precision of yeah, that question. Maybe precision about managing the system. I think not, because Flutter has a really good integration with the plugin system and the native packages, so you can build whatever you want to build on, say, Kotlin or Swift, and make that platform behave as you expect it to behave. And the connector you use on your Dart side is, it doesn't have to be complicated. So I think it's good. I don't know if that answers the question. If not, please take the time to write in the comments. And the other one, okay. What about Wasm and eWasm? That's an interesting question. Wasm and eWasm, for those who doesn't know what that is. I don't know what eWasm is. First time I've heard it.
Yeah, me neither.
But Wasm is a mode for compiling code to WebAssembly. That's what Wasm means. So you build, I don't know, code in C# maybe, and you compile it to work on the web. That's what it does. I think it has a lot of potential if used correctly. I think there are some great tools being developed and that are developed using Wasm. For the moment, for what we do, Dart compiles to Android, iOS, web, Linux, Mac, Windows, and embedded devices like chips and stuff. So also the command line you can compile to binary. So I don't know if we will need to use Wasm, but I think it's really good for those who are developing in languages that work well with it.
I think in the web platform, I think some it's been developed, the Wasm compatibility, so that's something to notice.
For that,
I was yeah, because maybe that I skipped that part. Dart compiles for the web. It compiles obviously to JavaScript, and they are kind of there is a compiler, the special compiler, which is called Dart2JS. They are developing some Wasm modules, so I think
okay.
That's where it goes.
Good, I didn't know. Okay, and there's another question that goes, how does Dart communicate with the blockchain? Do you want to take that one?
Yeah, maybe. All right. Dart has a community-made package called Web3 Dart, which is being continuously developed. That is the main package we use for communicating with the blockchain. Nothing else to be said.
No, it uses JSON RPC. That's the main thing on the back. So it's just HTTP request with JSON RPC format. So yeah, it's mostly the same way that Web3.js does it. Well, that's the way that Web3 does it.
Yep.
We have, that's a spicy one. What would you recommend for state management? So that's the eternal question. And everything that is reactive, you have, as with JavaScript and most of the reactive frameworks, you have lots of options. You have Redux, you have Mobix, you have Flux, you have all those options to choose from. The most basic one is the one that I show you. There is a local state, and you can have dependencies going from the top layer to the bottom layer. So you have a screen that has a variable, and that variable you pass down to the, I don't know, a column, and that column has a widget inside. That widget receives the same variable, so you pass it down 3 levels, and when the parent changes the value, you can see it reflected on the lower level. And that's the most basic. React Native works the same way, but it's a pain, because you always end up with like a lot of calls that come and go, and that go from the top to the bottom. It's heavy. So we use Provider. That it's a package that it's really good. It has migrated to what is called now Riverpod, and we are starting to build with it. So what it does is you have like a simple central repository of state, and you say, okay, from now on, I'm going to be using that state inside my app, and you listen to what happens on that state, and it reacts on the app. And also something that comes with Flutter, and it's a complex but really interesting paradigm is the streams paradigm. It's reactive, maybe as RxJS or with observers. So you say, this is my state. I'm going to be listening to everything that happens in this object. And whenever something changes, whatever is listening to that state gets notified and changed accordingly. We have one more.
Yeah. Do you recommend FBM package to manage the versions of Flutter? Definitely.
Okay.
Yeah,
so
maybe
we have an internal discussion. Yeah, go.
yeah. I use it. I don't use it. I really like it because it's in a seamless way. You can switch between Flutter versions, and that is awesome. I think it's really crucial to use. Ivan went the other way. I
like running in the jungle like a crazy person, so I don't use it, because when I started developing with Flutter, I just downloaded the binaries from the web and went with that, and I got used to using it. So it's not a matter of what's best for me. It's just what I'm used to using. But if you're starting with Flutter and you want to manage different versions, I would really recommend you go the FBM route, because you're going to end up with a lot of, I'm calling this version, no, I'm calling that version, and then you'll lose yourself really fast.
Yeah, it has some drawbacks on the configuration at the first times, but I think it's really great too.
Right.
All right.
Any other questions?
I see one that is not a question, but maybe a question. Background processing could be cumbersome. Yeah, I don't think that is a question, but if you're interested in launching some task to a new thread, you can, and it's really, really easy in Flutter. you don't have to manage threads, messages, or something like that. So it's really simple.
Yeah, there's a compute function that is really good for processing things on a thread that is not the main thread, so you don't lock your UI. You have to process like 20,000 entries from a JSON file, and that's going to probably block your UI. So you compute that on another thread, and when you're done, you message back, and it's done. It's really easy if you don't want to have a lot of mess with multi-threading and all those.
Okay, we are getting without time, so I want to say you that the talk was amazing. It was really good, and we really appreciate your participation. So thank you very much. Thank you everyone for participating. And well, I don't know if you want to say something else.
No, thank you very much for having us. I didn't show the last slide, that is the links, but if you want to throw that in the comments, it's our website, our Telegram, our Instagram. Come join us, come talk to us. We are working day and night. If you want to be sure we're working day and night, send a message on our Telegram group like Saturday 7 p.m. and you're going to see we are answering. So there's that. And yeah, thank you for everything.
Okay, thank you guys, and see you next scientific moment.
Yeah.
See you next scientific moment.
Obviously.
Bye-bye.
Bye-bye, everyone. Bye-bye. Bye, everyone.